In this lesson, we'll find the area of regular polygons. We're going to relate the regular polygon to a circle that circumscribes it. And by doing that, we can call the center of the polygon the center of the circle that it is inscribed inside of, and the radius of the polygon will be the same as the radius of the circle. Since the vertices are the only points on the circle, the radius of the polygon will always go from the center to a vertex. The line segment that goes from the center to the side of the polygon is called the apothem of the polygon. It is actually the height of the base of an isosceles triangle that's formed by two consecutive radii, which means that to two consecutive vertices. And this will form an angle in the middle that we call the central angle of the polygon. It would be a central angle of the circle too, but it's a central angle of the polygon when it is formed by two consecutive radii. We can always find the measure of that central angle simply by taking 360 and dividing it by side. So let's look at this one. Our center of the polygon is point P. The radius of the polygon would be line segment PM or line segment PN. The apothem of the polygon would be line segment PQ, and therefore it would be the height of that triangle, and my central angle would be angle MPN, and the measure of that central angle would be equal to 360 divided by the number of sides, which in this case is 6, or a 60-degree angle. So what you'll be asked to do is find some measurements, the angle of AFB. Well, since this is a 5-sided figure, we've got 360 divided by 5, so it's 72 degrees. Now, since the apothem is the altitude of an isosceles triangle, remember these two sides are equal, that means that it is also both a median, these will be equal, and it is an angle bisector, so these will be equal. So to find angle AFG, I just cut the central angle in half, so it would be 36 degrees. In GAF, then, if I know that this angle here is 36 degrees, and I already know this one is 90, then I can use my triangle sum theorem and simply subtract to get that that angle is 54 degrees. Now, here's what you'll be asked to do. Identify the center, a radius, an apothem, and the central angle. Well, the center, of course, is the center of the circle, P. The radii, there's two shown, PY or PX. The apothem is PQ, and the central angle is XPY. So I want to find these measurements, XPY. Well, since this is 4-sided, 360 divided by 4 is 90 degrees. So the entire angle is 90 degrees. Since this is a bisector, it makes each of these 45, which makes this other angle here 45 degrees. So I have a 90, 45, 45 for the answer of those three. Now, the area of a regular n-gon. What we're doing is we're thinking in terms of that circle and those triangles formed with my radii and the sides of the angle, and remember that the apothem will put it into two right triangles. And so what I do is I have a isosceles triangle with a base of S, which is the length of the side. The height of that triangle is simply the apothem of the polygon. And so I can get the area of the entire polygon by finding the area of that triangle by the number of sides, because there's another one of these congruent triangles along each side. Now, if I multiply 1/2 times the side times the height, so 1/2 base times height, times the number of sides, it gives me 1/2 ANS. Now, if I think about that, though, if I take the number of sides and multiply times the length of a side, what that really gives me is the perimeter. So a more convenient way of thinking about this area is it's 1/2 of the apothem times the perimeter, and that takes care of all of the triangles at one time. So the area of a regular polygon is 1/2 the apothem times the perimeter. So let's look at an example here. I've got this table. And for this table, I'm going to look at this triangle formed by drawing this radii and putting in the apothem here. Remember what we said, this apothem is the height, but it also is an angle bisector, and it also is a median, so it makes these two parts equal, meaning that this segment will be 7.5, which is half of 15. So what I'm going to do is first find my perimeter. We know that it's 8 sides, each side is 15, so my perimeter is 120. Now I need to find my apothem. Well, when I look at that triangle down there, brought down here, here is my apothem. I've got two sides of a right triangle, so I can use Pythagorean theorem and solve in order to get the third side, which is the apothem, 18.108. You can see I did the square of the hypotenuse minus the square of the leg and took the square root of that entire thing to get my apothem. Plugging into my area formula, I end up getting about 1086.5. So let's look at this one. In this one, all we're given is that radius, and we're asked to find the perimeter and area. Well, we have to find the perimeter in order to get the area. So to find the perimeter, I'm going to have to get a side of that triangle. So since I only know one side, I need to know an angle. So the measure of the central angle, since this has 9 sides, is 360 divided by 9, which is 40, which makes this part in here simply 20. So when I take this triangle and bring it out here and look at it, if my central angle is 40, then that angle is 20. Now I'm going to, if I know an angle and a side, what I need to do is find the other sides by using my trigonometric ratios. Since my angle is up here, if I'm looking for the length of the side, MK, then that is the opposite, and what I know is the hypotenuse, so I will use the sine of 20 degrees to find MK, opposite over hypotenuse, and when I solve that, it comes out that it's about 1.36. To find my apothem, which is that side, what I have is the adjacent in the hypotenuse, so I'll use cosine to get the apothem over 4, and then when I solve it, I can see my apothem is about 3.6. So that is the apothem right there. So in my regular nonagon, my side length is twice MK, so I did twice 1.36 to get 2.78, and my apothem's 3.76. So my perimeter is 9 times the side length, so it comes out to be 24.48. And then I just use my formula, 1/2 the apothem times perimeter. So 1/2 of 3.76 times 24.48 gives me approximately 46 square units. A little guided practice for you to try. Notice in this one, it gives you two sides of the right triangle, so you can find the third one by using Pythagorean theorem. So we can say that that is the square root of the hypotenuse squared minus the leg squared. That will give us this much. We know that we have to multiply that by 2 in order to get the entire side. And then we know that there are 5 sides to this, so we need to multiply that by 5, and that would give us our perimeter. So our perimeter would come out to be about 46.6 units. Now, how did we get the area? The area is 1/2 the apothem, which is 6.5, times that perimeter, which is 46.6, and that equals about 151.5. In this one, all we're given is a side length. So what I'm going to do is I'm going to remember I can draw this down here, drop in my apothem. My apothem's going to be there. My side length is 7, so half of that is 3.5. So in order to find the apothem or another leg, when I only know one leg, I need a central angle. So how many sides is this? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 360 divided by 10 is 36, and I need half of that for this angle, so my measure of the angle will equal 18 degrees. So in order to find the apothem here, I'm going to have to say, since this is opposite over adjacent, the tangent of 18 is equal to the opposite over the adjacent, which is the apothem in this case. So if I put that over 1, cross multiply and divide, I can see that my apothem is 3.5 divided by the tangent of 18. My perimeter, remember we had 10 sides, 10 times 7 is 70. So when I plug in my perimeter is 70, and when I plug into my apothem, my area is equal to 1/2 of the apothem, 3.5 over tangent of 18 times the perimeter, which is 70. That gives me my 377. Find the perimeter and area of this regular polygon. Well, this is a triangle, so this is an equilateral triangle. I'll drop this down here. I already know my apothem is equal to 5. I need the length of this side. So in order to get that, I've got to find me an angle. So 3 sides, so 360 divided by 3 is 120, and half of that is equal to 60, so this is a 60-degree angle here. I'm looking for this. So the tangent of 60 is equal to x over 5. So x is 5 times the tangent of 60 degrees. So if I want S, or the side, we'll call this S. And so S is going to be twice that, so that would be 10 tangent of 60. And since I've got 3 of these, that means the perimeter is 30 tangent of 60. So I have my apothem, I have my perimeter, I can plug into my formula and get these. Now, which one of those, and this should say 3 through 5, which one of these could be used for a special right triangle? That would be number 5. I could use that one as a special right triangle by remembering if this is 60, that's 30. So the length of x would be 5 times the square root of 3, which would give you a side of 10 square roots of 3 or a perimeter of 30 square roots of 3. Obviously, tangent of 60 must be the square root of 3.